Hello, Honors Higher Algebra students. This is Mr. Johnson, and this is the second lesson of Unit 10. And this is on solving exponentials by changing the base. And so what we're going to do is kind of exactly what it sounds like. We will work on the base of the exponential and adjusting the base in order to solve for an unknown variable. So for example, you can see in the opening slides here that we have 64, and 64 is obviously just 64 to the first. That could be written as 8 squared. So that would be technically a change of base if you wanted to write it that way. Now, the other way you could write 64 is 4 to the third. So that's just a different way of changing the base. So the base originally was 64. Now it's 8 with an exponent of 2, or it's 4 with an exponent of 3, or it's 2 with an exponent of 6. So 64 could be written in any of these three forms. And so any of those three would be just an example of changing the base, but having the equivalent number. So for example, 81 to the first could be written as 9 squared or 3 to the fourth. So you can change the base and you can manipulate it algebraically in order to solve an equation. So that's what we're going to do. All right. I expect you to know all of these. Basically, I expect you to know, 2 to the power of 0, 1, 2, 3, 4. I expect you to know beyond that, actually. I expect you to know 2 to the sixth as well. But then 3, I expect you to know 0, 1, 2, 3, 4. We really don't do 3 to the fifth. 4, and so on. So I expect you to know these. So if I say, what is 8 to the second power, I expect you to know that's 64. If I say what is 5 to the third, I expect you to know that it's 125. Most of these, maybe not some of the ones on the tail end here, but most of them you know from Algebra 1, and so I'm not too concerned about that. But just, you should know these without a calculator. You can certainly, as you learn and remind yourself of them, you can use a calculator to help you in your analysis of them, but you should know those well. Okay, let's try a really simple example. So we have 3 to the power of x equal to 3 to the eighth. Well, all right, you can see that the base on either side of the equal sign is 3. So the base is the same. Well, if the base is the same, then the exponents must be equal. And therefore, it's pretty obvious to see that x must be equal to 8. That's the only way to make sure that this equation is balanced. Okay, this is a little bit more difficult because we have 3 and 9. All right, well, clearly the bases are not the same, therefore the exponents can't be the same. So what we want to do is we want to try to figure out how to make those two bases the same base. The easiest way to do that is to use the fact that, so this is a fact that 3 squared is equal to 9. Okay, so if I have on the left side 3 to the power of x, and instead of 9, if I write 3 squared, now keep in mind that this 2 right here is still there. I'm not getting rid of that. All I'm doing is I'm rewriting 9 to be 3 squared. So this little part right here, 9, is written as 3 squared. So I'm rewriting it in its equivalent form. Now what I'm going to do with this is I'm going to take the left side and not change it. So the left side is 3 to the x. The right side is 3 to the second, so 3 to the second power, which is a power to a power, and I multiply those powers to get 3 to the fourth. Well, now the bases are the same. And so if the bases are the same, then the exponents must be equal. Okay, let's try another one. So we have 8 to the power of x equal to 4. Now again, your entire goal is to get these bases right here to be the same. And so you have to think through and maybe even go back to that table that we had on the previous page and say, all right, which base could I write in such a way that I could get 8 and I could get 4? And that's where that table is going to come in handy in terms of just your knowledge of all of those values. Is that the faster that it is for you to analyze those, the better, because we can see 8 and 4. We know that 2 is a common base between the two of those. So instead of 8, I'm going to write this as 2 cubed. And instead of 4, I'm going to write this as 2 squared. Oops, sorry. Okay, so I'm going to write 8 as 2 cubed and 4 as 2 squared. I'm going to use my properties of exponents to write this as 2 to the power of, remember we multiply those, so that's going to be 3x, and obviously I'm going to keep this one because I want my bases to be the same. So now that my bases are the same, and remember my bases are right here, 2 and 2. If my bases are the same, then my exponents, so that doesn't work at all. Let's do this. No, that also doesn't work. All right, that's fine. I'll just leave it. So the exponents, 3x and 2 must be equal. And so therefore, x must be 2/3. Okay, let's try another one. This one's a little bit more complex. So we have 32 and we have 4. So I go back to the table that I'm thinking of. I mean, I know that 4 to the first is 4, but can I do anything with 4 to get 32? I can do, 4 times 8, but that doesn't really help me because I need to use powers for this, not multiplication. So what I'm going to do is use 2 again. 2 to the 5th power is 32. That's one that you should have memorized. This one's a little tougher because I have 1/4. So remember, 2 squared is 4, but if I make it 2 to the negative 2nd power, that's going to give me 1/4, because remember the negative properties, that would mean that it would be 1 over 2 squared, which is 4. So we have 2 to the power of 5x on the left and 2 to the negative 2nd power on the right. My bases are the same. Therefore, my exponents are the same. So x is equal to negative 2/5. Okay, we're going to solve for x. This one's kind of similar to the other one, where we have this fraction on the left side. Now, I know that 3 squared is 9, and so if I want 1/9, I can make this 3 to the negative 2nd. That would be the equivalent of 1/9, and this is going to be 3 cubed. Use my properties of exponents on the left side. My bases are the same, therefore my exponents must be the same. So x is equal to negative 3/2. Okay, I'm dealing with 2 fractions now for number 6, which means that I'm not going to actually bother turning them out of fractional form. In other words, I'm going to leave this right here, okay? And over on the right side, I'm going to make this 1/2 to the 2nd. Now, you have to be really careful that you don't change the value of the problem. So, in other words, 1/2 to the 2nd power is the same thing as 1/4. Because remember, if I take this out just for a second, and then I'm going to erase it, this is the same thing as 1 squared over 2 squared, and 1 squared is 1, and 2 squared is 4. So it's the same thing as that. Okay, so let's get rid of this extra stuff here. Okay, so then what we're going to do is take a look and say, okay, do we have the same base? Yes, we have the same base. The base is 1/2, and therefore the exponents must be equal, which means that x is equal to 1. All right, our next problem, we have 5/2 and 4/25. So we need to try to wiggle this around in order to make these the same. Now, if you notice, I know that 5 is sort of connected to 25, because 5 squared is 25. I also know that 2 is connected to 4. So that means that these fractions are kind of flipped upside down from where I want them. So this is the first thing I'm going to do, is I'm going to make this 2/5 to the negative 1st to the power of x. So remember, if I have 2/5 to the negative 1st, that's the same thing as 5/2, because of that negative exponent property. I'm going to leave this as 4 over 25 to the 3rd. Now, one thing that students will often do is they'll say, okay, I want to make 4 over 25 like that. Actually, you know what? I'm going to write this over here. Hold on. Okay, so they're going to say, all right, I'm going to make this 2/5 to the negative 2nd power like that, because I know that that equals 4 over 25 to the negative 1st. So they're trying to force the base. You have to be really careful with this, because if all of a sudden you take 2/5 and you square it, you've now changed the problem, because 2/5 squared means that you're not rewriting it, you're adding to it. So instead what we want to do is we want to take and leave this one. I'm going to make this 2/5 to the negative x. I'm going to simply rewrite this one 2/5 to the second, because notice that that's equivalent to 4/25. In other words, let me highlight it. This is equal to that. Those are the same. So all I've done is rewritten it. I haven't adjusted it. If you square this side, now you've adjusted it, and that's a problem. Okay, then what we have is, let's see, we're leaving, we're leaving this one to the negative x. This one is now 2/5 to the 6th power. So the bases are the same. That means the exponents must be equal. That means that x is -6. Okay, I have 1/2 to the x minus 1, and I have 8. I'm going to leave the stuff on the left. And I'm going to make this, let's see, well, let's do it in stages. This is 2 cubed, right? But I want 1/2. So what I'm going to do then is make this 2 to the negative, it's not at all what I want. I'm going to do this 1/2 to the negative 3rd. So again, I haven't changed the fact that it's a power of 3, but I've made it a negative, which means that 2 to the 3rd is the equivalent. So let me write it over here. So 2 to the 3rd is the equivalent of 1/2 to the negative 3rd, because remember the negative will reciprocate, which means that you get 2 to the positive 3, and therefore you have these two things equal. Okay, so since the bases are the same, then the powers must be equal. And there you go. This one's kind of similar as the other one. We have these two values that are kind of connected, and these other two are sort of connected. So let's go ahead and switch one of them. I think I'm going to leave this one. There's kind of different strategies you can take. I'm going to make this one the reciprocal, which means that my power is now negative. Okay, so again, this is equivalent to that. If you don't believe me, type it into the calculator, you get the same thing. Okay, I'm going to take my 4/9, and I'm going to make it 7/3 squared. Okay, so again, just to reiterate what we're doing here, this 49/9 is the equivalent. That means equal to that. So again, type in 7/3, that quantity squared, you get 49/9. So it's equivalent. We can't change the value of it. We can just change the way it looks. Okay, that means that over here on the left side, we have 7/3 to the power of 2x. And over here, we have 7/3 to the power of -3/2. Okay, so the bases are the same. That means that my exponents are equal. So I have x equal to negative. Now remember, if you take 3/2 and divide by 2, now that's -3/4. All right, I believe this is our last one here. So we have 2 to the power of x squared minus 3x. And we have 16, which is 2 to the 4th. So the bases are the same. That means the exponents must be equal. To solve this, we could use the quadratic formula, or we could factor and solve. Factoring and solving is way easier. So we have x equal to -1 and +4. All right, there you go. So in Schoology, you have a change of base Schoology quiz, and that will be the assignment. Thank you.